1, 2, and 3, the one in the X, which is the domain, the one in the domain, X is the domain. X is the domain, and capital X, not small x. And small x will be the one taking the values 1, 2, and 3, which is the element inside X. So that's called, small x is the input. And then the domain contain all the inputs. Now I said that those input, they're usually called variables. And those variables, they are called independent because they do not depend on the right-hand side, the one that is in the set Y, which is the range. However, the set Y, if you take the value 2, 4, and 6, they are dependent on those ones. So you have to first pick 1, 2, and 4. Then you create the second, you bring the second pair. So that's what makes them depend on the output. So it depends from the input. So usually call them dependent variables. And they are represented by Y. In fact, you can use Z and so on and so forth. So usually we use generally Y to represent. So that's why in the high school, when you define a function, usually you baptize it or automatically from the start, you call it Y equal to f of x. So that's the whole notion behind that. All right. Now, since these are things about numbers, so I think you guys, you all understand the numbers, you all understand which ones are odd, which ones are even. I'm not going to go into that. So, but because when we get to functions later on, we're going to define a different notion of odd and even functions, odd function and even function. However, I believe that you already know what is an odd number, what is an even number by now. All right. Now, which means that in those relationships, so now I'm going to get, for those who have the book, in those relationship, if you have a Venn diagram that is contain, let's say, element inside, let's say this is X, which is contain X, and you have another Venn diagram which is contain Y, which is the send. So what the first one is the domain, and the second one, let's say, is the range. So you have input and you have outputs, right? So in that input, I said a relationship is a function because it defines the pairs. So let's see if I take in the range, I take Y, and I take again also Z, right? And then if I take 1 here and then 1 here, so that's similar. I take a relationship that for one value, for one input, it gives me 2 different output, right? Can you tell me that is this relation is a function? Yes or no? You see, we're trying to create a relation R that give us the pairs x, y, and then x, z. Are these different? Yes or no? So you see, if you look at the pairs x, y, okay, maybe I should give it as a homework, and then it's people not talking x, z, right? You have this pairs x, y, and x, z are different if you look at them in terms of pairs, right? So, however, if these are different, now, does it make this a relation, yes or no? The pairs, I'm not talking about the output input. So I'm talking about the pairs. You see, for the pairs is the relation. However, now if we look at it in terms of a function, so let me define a function first because I haven't defined a function for you. So you can be able to identify the difference. So let's define a function. Generally, you see, from what I mentioned earlier on, when I use the Venn diagram, I said if I have an input and I have an output, then from here to here, I use something which is called a function f. So here you have a capital X, capital X, and then here you have a capital Y. This is you have a small x, and then let's say here you have an output, you have a small y. So now we're going to define what is a function. Or in other way, you have inputs here. And then the machine bring out something out this side, which that machine is called f now, instead of we starting with the relation up. So now let's define it, how we explain it in a word now. We're going to now take a definition. So I'm going to say DEF is definition. Now in this definition, I'll be defining a function. A function may be denoted maybe by f, or maybe I should say a function f. Usually a function f may be from, not a function f from a domain or from a set x, from a set x to another set y, from a set x to another set y, basically we are imposing some rule. So basically we're just imposing some rule, and earlier on we said that we are assigning. So is that it's assigns. It assigns, let's say, a unique. So I need to define it because of that example I wanted to give just earlier on. That example was doing a relation, but it was not doing a function. So I'm trying to first define what is a function before we can get to it. Say a unique, maybe I should also say a single or singleton, a unit single, not singleton, a unit single element because of object. Remember I call those inside, those are called single element. Single element, maybe I'm going to call it Y, single element Y, to a unit single element or output Y equal to f of x, and that is actually an element of Y. To each element D. So this is done to each element in the, to each element X, actually, to each element X in capital X, right? So basically that's what the function where we are creating a rule by ourselves. We are making a rule, and we say that that rule assign to each output one single input. That's what we are saying. To each I mean to each single output one input. That's what I'm saying. Now, the output is what we call the range. The input is what we call the domain. Is that clear? Now, let me put it now in a proper Venn diagram. So now if I have let's say A, B, and C, then here with a function f, here is going to be f of A, then f of B, then f of C in that bracket. So which means that if it happened by any chance, that f of B equal to f of C, so let's say for A, I assign f of A. For B, I assign f of B. So I assume that f of B and f of C is the same. So in a sense, this is what I'm saying, that this f of B is equal to f of C inside that set of range B. You see, I said, look at the definition. I said to a unique output, I have one input, right? Now, for who can tell me, is this a function, yes or no? F of A is equal to F of B. Is the output unique? Yes. So the input, I didn't say anything about it. I can take two input, they give me one unique output. So that is what is in a sense. So this is what I'm trying to explain. So the output must be unique. So which means in a sense, the earlier definition that I said, if you have it, so this is the function. If you have it like this, A, B, and C, you have f of A, f of B, and then f of, let's say f of A, f of B. And then I stop there. And then you have f of A here, f of B here. In fact, let me have also f of C. F of C here. But then you have f of C is also there, right? So you see, C is going to two different elements. So it means that there is no unique output. So there are two different outputs going to a unique input. So that makes it not a function, this one. However, the first one, you can have different input giving you one single output. That is okay. But the single output must be unique. All right. Now, you have an idea of what a function is. You have an idea of what a range is. So I can literally now go and use the proper mathematical definition. Now, the question is that, what is a relation? So in terms of a relation, you see, in terms of a relation, if you take this one here with A, B, and C, and giving you an output, C giving you two different outputs, right? C is one single output giving you two different outputs, so it makes it not a relation. So it's not a function. However, if you have two different input by giving you one single output, so then that is a relation, or which is the relation become a function. Remember, initially we called it a relation. The relation is we are trying to order the pairs, and then after ordering the pairs, we try now to define what is a function. And I said a function now for those ordered pairs, you have to have a unique output that goes to any other input. So I didn't say anything about the input must be unique. However, the moment you have one input that's going to two different output, then that is no longer a relation. And if it's not a relation, then it's the relation, however, is not longer a function. So which means that a relation can be a function, and there are instances where a relation cannot also be a function. Is that clear now? So we can associate now the difference between the two. And then we have already defined what a function is, right? Okay. Please, you need to stop me anytime if you feel like there are some things that I need to explain. Now I'm going to define what is functions in a different sense, right? In a different sense mathematically. So I move more to the mathematics because I think you guys are going to be doing mostly in mathematics. I'm going to give an example. I don't sure if I should call it example one, as we'll have many of those. In example one, let's say I'm going to use the definition that you guys all are aware of. I'm going to say let y equal to f of x, and then that is defined by x squared. So y equal to x squared, right? If y is equal to x squared, so that is the function. I mean, you can start by y equal to x, or y equal to x plus 1, right? So if you define another one, y equal to, let's say, g of x is another one, which is equal to, let's say, x minus 1. That is another function, right? That is another function. However, someone else can define another one. You can take it to the church and then baptize it as h for Hector. You can define it as 1 divided by x plus 1. That's another function, isn't it? And then so on and so on and so forth. There are several functions. Let's give an example. I can take the square root of x. We can, again, give it another name, maybe k of x. And then going forward, so I don't have to call it f of x or g of x or so on. So I can just then say, okay, you know what? It's general baptism in the church is giving it the name y. Then I'm just going to write it as y. You can say, okay, y equal to square root of x squared. Or you say y equal to square root of x squared plus 1. Or y equal to 1 divided by square root of x. Or minus 1 divided by the square root of x minus 1. And so on and so on and so on and so forth, right? Then, in this, the idea is that how do we get the range, or how do we get the calculation, right? Now, if let's say I start defining, let's say I pick one of them. I'm going to pick this one that I called minus 1 divided by the square root of x minus 1. Let me call it f of x instead. Now, if I call it f of x, now I'm going to now push you to the problem of range and domain, right? So let's say I want to compute f of 1. Who can calculate for me f of 1? F of 1 is equal to what? Can you compute f of 1? Possibly, if you can. What is f of 1? Guys, are you here in the meeting? Am I audible?
Yes,
or am I
sir.
just talking? Okay, what is f of 1?
So f of 1 will be undefined
Sorry?
because you'll be dividing by 0. Will be undefined because you'll be
f
dividing
of
by
1 is
0.
undefined. Well done. F of 1 is undefined. Okay, can I compute f of 2? Can I compute f of 2?
Yes.
Yes, I can compute f of 2, f of 3, f of 4. Can I compute f of, let's say, half, or f of, let's say, minus 1? Can I compute f of minus 1?
No,
No, why?
it will be square root of a negative number, complex numbers.
Who's talking? Malaji?
No, Botelo.
Ah, okay, because your voice sounds familiar as if one of those tutors. Okay, so which means that because of the negative, you cannot say minus 1 divided by square root of minus 1, which is minus 1 divided by square root of minus 2. So by definition of the square root, those things are not defined. Now the question is that how do we find the domains? Now let's start from the first one and then we come to this. So now basically you have an idea. So let's say if I take x squared, f of x equal to x squared, and I want the domain. So let's start by the first one. Or is it any? If I take f of x equal to x squared, can I calculate f of 1, f of 2, f of minus 1, f of minus 100, minus 3, f of 0? Can I compute all of those? Yes
Yeah.
or no?
Yes.
Yes. So which means that I can compute even f of half, f of quarter, f of pi, f of e. And when I say pi, please don't get hungry and start thinking of pi or food. Uh, so, and then don't start thinking of pizza as well. So you see, now, because this one, I can compute any number. So you mean the input is this x inside. This input can be anything. So if the input can be any number, so what do we say about the domain? What will the domain be?
X is the element of real numbers where
The domain will be, now I'm going to use a definition, mathematic definition. For writing domain, I write D with a F next to it. So if the function is baptized as F, then the domain is DF. If the function is G, is DG, DH, and so on and so forth. Then the domain is the set of all real numbers. Thank you, again. Now let's look at the range. You see, if I pop in any value, I get a different Y value, right? For each value that I pop inside X, for every input I put inside, any number I put there, I get again any other number in Y. So what will you say about the range?
it's unlimited up to
The
infinity.
is unlimited up to infinity. No, no. Can it go unlimited up to negative infinity? So what do we call it? What do you call the range? So we also write it as RF. The range will be also the set of real numbers in this case. So because it's any number. So now by deduction, again, if I take g of x equal to x, then the domain of g, I mean, you can put any input. The domain of g is the set of, and then the range is also the same thing. The range is also the set of all real numbers. So the range of g. So the domain and the range is the same. The same for equal to, let's say, x plus 1 or x minus 1. Now let's change slightly. I'm taking another function, let's say h of x, given by 1 divided by x. Let's say just, or let me take, let's take minus 3 divided by x, just for the sake of changes. Can I calculate f of 0? I mean h of 0. Can I compute h of 0?
No, sir.
No.
No, because you just said that you cannot divide by 0. Can I compute f of 3?
Yes.
Yes.
Can I compute f of minus 3, f of minus 100, minus million, 10, f of e, f of pi? Okay, so which means that we have all those real numbers, but there is only one problem. Where is the problem? The problem is the 0, right?
Zero.
Then we can say is the set of all real numbers exclude 0. You see, the domain will become now all real numbers excluding 0. So you remember earlier on when I wrote that excluding, so some people can write it like this: all real numbers minus only that set 0. 0 on its own there is just going to be singleton, which is just the set of 0 only inside it. Set of one element, and that element is 0. This is how you write it mathematically. However, in terms of interval, where I'm going to show it slowly, slightly, you can write it as minus infinity up to 0, union 0 up to positive infinity, as the one this guy has just said it to us. So it means we're only removing 0. We can take the domain can be anything, but it can never be 0. However, then how do we define it? Mathematically, we just say h of x is defined, let me say first, is defined if x is different from 0. Or you say for all real numbers, but x is different from 0. The moment you write it like this, it's already known that it's all real numbers excluding 0. Because of that division. Now we're going to move slightly different. I'm going to take a different example now. Let's say g of x equal to square root of x. You just said that I cannot compute square root of minus 1, square root of minus 2, of minus 3, and so on and so forth, because square root is undefined for negative numbers. So then automatically, if the square root is undefined for negative numbers, using this notion that I've just brought into play, then we can say G is defined if X is greater or equal to 0. So it's all the set of real numbers that are only positive. Then the domain of G, so we're coming to the range, don't worry. The domain of G will just going to be 0 up to positive infinity. Or some people write it like this, the set of all real numbers positive. Others write it actually with a positive on top, but generally the positive at the bottom is the one that is mostly used. So that's the set of all positive real numbers. Great. Now we realized in this option, we're realizing that in some instances, you can automatically think of the domain and the range. So now let's look at G of X. Let's say if you put square root of 0, what do you get? 0. If you put square root of 1, what do you get? 1. If you put square root of 2, you get a positive number or a negative number?
Positive number.
So which means anything that you put into the square root is actually a machine or a relation or a function that turn everything positive into a positive. So everything that inside, so if I baptize this by a y, so which means that y, every input that I put, it's just that machine will transform it into a positive input. That machine, it doesn't have negativity there. So if anyone telling you so much negative things, just put him under the square root. You will turn him into a positive person. Great, if that's then that is telling us that if y is, we baptize y, you remember y is what we call the output, which is inside the range. So it's already tell us if x is positive, which is the interval from 0 to infinity, which is r plus, which is the domain, and then y is also positive, then automatically y will be the range. So we say also the range of this function, the range Rg is going to be 0 to positive infinity, which is R. So you see, these are just some specific examples where the range and the domain are the same. However, there are some instances when the range and the domain are not the same. So let's see those ones. So let me take you a function, let's say g of x, I should have changed from g, equal to, let's say 1 divided by square root of x. In fact, I can just take 1 divided by square root of x squared, let's say minus 1. In fact, we don't even need to take that difficult one. Let's take it easy in that format just now. I can just make it, let's say, square root of x squared minus 1. Just let's start by this one first, right? If this is my g of x now, right? How do I get the domain? Using that context that I just used. What did I do? You see, earlier on when let me go back here. When I gave you that g of x equal to the square root of x, what did I say about x? I said x must be greater or equal to 0. So which means anything under that radical, you see that r is what is called radical, I mean that square root. Anything under that square root must be positive. Now, here for this case, what must be positive in this case? What can I say that it must be positive? I said anything under the square root must be positive. For me to get the domain, anything under the square root must be positive. So I'm going to say x squared minus 1 is greater or equal to 0. That's the way to get the domain. And then how do I solve that to get the domain? Who can give me the idea? There are several options. There is an algebraic, there is visualization, and then so on and so forth. And then there is miracle, please. If we can go to the witch doctors there, or the Sangomas, if there are Sangomas here, let them give us the answers. Yes. Guys, tell us. X squared minus 1. Sorry?
You are going to
Solve
transpose
the x.
Transform the x. How?
transpose x is going to be x squared
Transpose x squared
yeah,
greater than.
or equal to positive 1.
Okay, is that what you want? So he says x squared greater or equal to 1, and then?
Then you square root both sides, which means it's going to be x is equal to the square root of 1.
Yeah, I'm going to write it in red. But don't be scared. Don't run out of the meeting. Say that because it's written in red that I'm going to be oh, damn, I think we're finished. And I didn't even save. Sorry guys, let me locate it. This is kill me, I think. 3-minute discussion has gone. Okay, it's fine, it's here. Okay, I said x squared minus 1 is greater or equal to 0. And this guy said x squared greater or equal to 1, and I said that I'm going to put it in red color. He said that you're going to take the square root this one and the square root of this one, and then you said on the left hand side, what do you get?
X is equals to 1.
Where we have greater or equal. Where did the equal come from?
I was mistaken.
How did you transform the greater equal to just equal?
How did I do what?
You see, you said that you said from x squared minus 1 greater or equal to 0 would transpose 1 on the right hand side, which I did. So you have x squared greater or equal to 1. Then I asked you what next. You said take the square root on both sides. So square root of x squared greater or equal to square root of 1. I did it on the same line. Then I said to you, what do you do from here? You said write x equal to 1. I'm asking now, from square root of x squared greater or equal to 1, how did you end up from the greater or equal to just get x equal to 1? That was my question.
We have two options there. Remember, it's greater than or equal. Now we're equating equal.
But then the two options just become one. Or how? Okay. Where are the two options?
Or again, you can say.
Okay.
Yes.
Or
X is not equal to -1.
x is not equal to -1. You see, now you made it even worse. You see, you added from greater or equal to, you created something called equal, and then you created something called not equal. Mathematically, that's how we write not equal. It's not a hash, but it's just an equal sign and cut in the middle. Cut with just a small line. So you see, guys, just let me advise you, this is not the right thing of doing it. So if you go in the assignment and you do like this, you will see I'll put for you 3 kisses. 3 kisses means that I'm not going to give you any mark going forward from here. If you get, so which means that the marks here, you can get it, but you cannot get the marks that are here. You won't get a continuous mark. If you see CM I write in your script mean continuous marking. Continuous marking means that even if you make a mistake on your first step, and your next step makes sense, then means that you can still, you might not get the full mark, but you get like some half of it or some quarter of the mark. You get some marks for it if the word you wrote it makes sense. Okay, let me try to explain why what he's doing is not correct. Okay, you see, we said that x squared, let me change it to black. X squared minus 1 is greater or equal to 0. To solve this, don't just pass them left, right hand side and substitute. Okay, in fact, first of all, before we solve this one, there's something I need to bring to your attention. Before we solve this, there's something that I need to bring. You see, when I earlier on define a square root, if someone gave you the function equal to square root of x, it means that x is positive by definition. However, if someone gave you this square root of x squared, what can you say about x? Can it be positive or negative? Can you pop any value there? Yes or no? We said earlier on that this, yes, you can pop in any value. You can pop even the negative. You see, as opposed to this one, if you have just the square root of x, you cannot pop in negative value because you just said earlier on that the square root is a machine that transforms everything from positive to positive. It does not take negative. When you put negative, it makes it undefined. However, x squared by itself is always positive. When you take anything, you put it inside x squared, even a negative can turn into a negative. Great. So those negative guys with too much negativity, put them into x squared also, right? So which means that x squared will turn them into positive, and then square root of whatever that positive will just turn it into a positive. So because x squared can never be negative, it will always be positive. It's not like x. So which means that if you have the square root of x squared, unlike the square root of x, which does not take negative, the square root of x squared take negative. Now I'm going to take another one. And I'm coming to this, I'm not done with it. Let's say you have the square root of x and then the square. You see, this squared outside already tell us that the square root of x inside there cannot be negative. I mean, x cannot be negative inside because the square is outside the square root. However, if the square is initially inside the square root, you can put any negative value. If the square is outside the square root as an exponent, you cannot put a negative value there. Now the question is, how do we relate all the three? So you see, this square root of x, all of it squared, is equal to x, but this will always be a positive number. That's the difference. So now, which means that by simplification, if I have a square root of 2, all of it squared, it become 2. Square root of 1, all of it squared become 1. Square root of 3, all of it will become 1. That is the last one. Now look at this one. I'm going to go to red. You see here, this one will also always be positive because it's the square root of something squared. Now the question is, the input is the problem. The input can be anything. It can even be a negative number. This one that is inside, I'm going to put a bracket inside here, can be anything. So as opposed to this one that is in here. So you see, because it can be anything, now the question is that, you see the one last I said, square root of x squared is equal to just x, and that x will always be positive. However, this one here, it gives you two different answers, plus or minus x, because the input can be anything. It means that the square root of when the x is not known is plus or minus. So you got my point. I'm not saying the square root of 3 is of 3 squared is minus 3. No, I'm saying when it is not known, the square root of x squared is always plus or minus x. It can even be a negative. It means that the input can be a negative number or it can be a positive number when you simplify it. Because that negative number, the moment you put it inside the square will transform it into a positive, then the square root is happy. Say, okay, x squared, you are giving me a positive number. I'm happy to put it in the machine. Let it go through. It output is positive. The one last is say it doesn't take anything negative. It only takes something positive. So you see here, we have a problem here. You see on the right hand side is greater or equal to 0 in red. Let me make some blue color to tell you where the problem is. If you look at this one here, you might think that I'm saying minus x. No, minus x means that if x is negative, you're going to multiply it by another negative to make it positive. If x is positive, you keep it as a positive on its own. That's what it means. That's why the right hand side say greater or equal to 0. So the input, you see on the left-hand side, you see a minus x. So it says that if x is the negative number, you multiply it by another negative, then it becomes positive. That's why it goes inside there. That's not the same with the one that at the bottom. So now look at this. What does this does to our inequality now? We are going back to our inequality before we end up our discussion. So we are saying we are looking for the domain of a function g of x equal to the square root of x squared minus 1. And then I said, before we get the domain, there are some acrobatic move that I need to take, which is x squared minus 1 greater or equal to 0 by the definition of a square root function. The square root function says you can give me anything inside under condition that that thing must be a positive number. So for that to happen, for us to get the domain, we say we have a restriction of from the square root x squared minus 1 must be greater or equal to 0. That's the first thing. Now, x squared minus 1 greater or equal to 0, it doesn't mean I take it to the right-hand side, I transpose it, and then I take the square root. No. So here what we do is that we do something that you often do in high school. We say difference of two squares. You guys remember? So x squared minus 1 can be written as x squared minus 1 squared. And then you apply the difference of 2 squared is going to be x minus 1 times x plus 1, and that is greater or equal to 0. Now you're going to devise a new plan. The new plan is what you call a table of values. In the table of values, you have what is x. You see, you answer yourself, when will this be 0? This will be 0 when x equal to minus 1. And it will also be 0 when x equal to 1. So then you put a 0 here, and then you put another 0 there. Then you write x minus 1. And then you write x plus 1. This is called a table. Then you write the product. So you can write it as a p, or you can write it as x squared minus 1. Now the question is that others, they just like it to go to straight. Because I wrote it as a product. So you see, which means that x minus 1 becomes 0 at x equal to 1. I think I exchanged the positions. X minus 1 becomes 0 x plus 1 becomes 0 at x equal to minus 1. So it means that anything before it becomes 0 is negative, and anything after is positive. And then the same for x minus 1 becomes 0 at x equal to minus 1, at x equal to 1, sorry. Then anything before that becomes 0 is negative, anything after the 0 is positive. Now the product means you take x plus 1, you multiply by x minus 1, because earlier on I wrote this as x plus 1 times x minus 1 using the difference of square. Then this becomes 0 here and 0 here. So which means that I take minus multiplied by a minus become plus. I take plus multiplied by a minus become a minus. And then I take plus multiplied by a plus become a plus. So what does it mean? It means, I'm going to use a different color now. Minus 1 and 1 are in red color. So it means that anything before minus 1, x squared minus 1 is positive. Anything after 1, x squared minus 1 is positive. Anything in between minus 1 and 1, x squared minus 1 is negative. So what does it tell us? It tells us that for the x values that are smaller than minus 1, x squared minus 1 is positive. For the x values that are bigger than 1, those input that are bigger than 1, then means that the x squared minus 1 is positive. And then for the x values that the input that in between minus 1 and 1, x squared minus 1 is negative. Now look at what do we want. What we wanted was, we said x squared minus 1 must be positive, greater or equal to 0. So then at the same time, we said difference of square x squared minus 1 times x squared times x minus 1 times x plus 1 is greater or equal to 0. So which means that we only consider the places where x squared minus 1 is positive. So then we say those x values, we say x is lower, below minus 1, or x is greater than 1. So these are the input that we look. So this is what it gives us the range. Now, how do you write this in terms of a range or in terms of a set? Remember, the range is the set. So now if we write in terms of set, the first one we say is the interval. You say, if you write it in terms of a straight line, so let's say this is the set of real numbers. So minus 1, let's say 0 is somewhere here, minus 1 is somewhere there. So anything below is somewhere there. So this is the one we look. If 1 is here, then anything, if this is 1, then anything after 1. So 2, 3, 4, or let's say 1.5, 1.1, 1.001. All those are what we want into our input. So then we're going to define it in a set form. So in a set form means everything after minus 1 is negative. I mean, before minus infinity to minus 1, and then it's closed here. And then the or I said is the union from 1 up to positive infinity is round bracket and closed because of that less or equal or greater or equal. If this was a strictly less than 1, strictly less than minus 1, strictly greater than 1, then the square bracket will turn into a round bracket everywhere. Great. So this is the domain for G. So d of G, so is that one. Minus 1, I mean minus infinity up to minus 1, union 1 up to positive infinity. Now with this in hand, okay, I'm not sure, someone is making a lot of sound. Okay, since we have reached the time, so let's the purpose of the discussion is not only to tell you the mathematics, but also to tell you when we should stop. So we bypass it by actually 4 minutes, and let me consider those 4 minutes as what do I call it, as part of the stop record and stop record and go record and so on and so forth. So I'm going to say what is this guy name? Visa will get the next recording in pieces. Don't think of piecewise defined function. So whatever comes next, Visa will take and then cut it in 7 minutes and then send it back to us. Great. Now, any questions before we stop?
Are we still submitting the assignment tomorrow?
Yes, you can always submit. If you don't submit, it's also not what do you call is not It's not a problem because I'm going to ask for an extension. So I will send an extension just shortly to the DSAA, the assignment department.
Okay.
So you can get extensions.
So when will we get the announcement for extension, tomorrow? Or...
Yeah, first when I get the thing from her, I will let you know.
Okay.
Sir, can you please do the range of this one that we were doing right now?
Okay. Just a second. I'm just from 22 May 2026 to it's 2 weeks will be enough, right? 2 weeks is enough
Yes.
for an extension, right? Let's say
Yes.
okay, more or less. I'm going to give you more or less.
Are we going to have another class after this one?
No, we
Before
have
submit.
covered already everything in this one. So what we do is that we can have another class. I don't know. I'm going to check my free time. Then I will put an announcement. So what you do? Can you please tune to the model site for update? So you check the announcement. You check the what do you call the mails, so that at least you make sure that there is a link or there is an announcement for the next discussion. Let me get back to you guys here for this one. Any hand, guys? Any other question? Oh, she asked. Someone asked. Was it Letitia or who?
Me, sir.
Okay. Let me go here. She said she wanted the range. We said our function was, let's baptize it, y equal to g of x equal to the square root of x squared minus 1. Great. How do we get the range for this? Who have an idea now, since we have done the domain? How do we get the range? For the domain, did we exclude anything? We exclude a lot of things that in between -1 and. So if you want, let me just rewrite this in a different form. You see this set here where I said minus infinity to -1 uses 1 union 1. You see, when you look at it, I took everything before -1 and everything after 1. However, everything in between -1 and 1 I didn't take inside R. So which means that this you can literally write it as R excluding -1 and 1. Or you can write it as R excluding -1 and 1. So another way you have also. When we write -1 and 1 in bracket, it's like this. So it's this piece here. -1 and 1 in the set of real numbers. So this is from here to here. So if this is the set of real numbers, then that's -1 and 1. Okay, let's get back to our question. We want to calculate the range once we get the domain. How do we calculate the range for this function? Right? Who can tell us how do we get the range for this function? Tell me. How do we get the range? Come on, guys. So which means that all this time I've been I've been working. You guys, you haven't grasped what I was saying about the range and the domain. How do you get the range? So we got the domain using the technique x squared x squared -1 greater or equal to 0, right?
Yes.
So how do we get the range? What do we use? Okay, let's come here. Now let's look at it in a simple way, right? I said x squared -1. If you can put anything inside x squared, right? So which means that if you can put a negative value or a positive value inside x squared, it's going to be fine. The only problem is you cannot put anything between. You cannot put a half, you cannot put quarter, you cannot put 0, you cannot put let's say minus 0.99. You cannot put, let's say, 0.99 and so on and so forth. So everything that's in between minus 1 and 1 is the one we're going to remove, right? Now, but the first aspect of this, there are two things that we need to say to show. When I showed you that the square root of x, I said that the range is always the y value that positive. Everything that you put inside this square root x squared minus 1 is going, the square root will transform it into a positive number. So that's one thing. But that positive number is which positive number? It doesn't mean that your input will be between minus 1 and 1. So now the question is that that's the one we need to solve now. So how do we solve the problem that is in between minus 1 and 1? To solve this problem, we take x squared minus 1 equal to 0. So it means that, you see here, x squared equal to 1, then you can take the square root both sides, and then you write it as...
Okay, I see now.
Yeah, you see, here is where you're allowed to take the square root. You write it as plus or minus x, the left-hand side, equal to 1, because square root of 1 is 1. 1 is already positive. The left-hand side, we don't know. We write it as plus or minus. Then we transform it. We say that we transpose the plus or minus to the right-hand side. Then we write as x equal to plus or minus 1. We are trying to now decompose our problem so that we can figure out what do we remove from our range. Remember, I said that y value, if you look at it here, I said that y must always be positive. You see on the right-hand side, let me put it in red. You see this, I said that the square root of x squared minus 1 must always be positive for me to get the range. But now I'm trying to figure out where exactly for which input is that the problem. So then I start with the problem, which is x squared minus 1 equal to 0, which is the problem is between minus 1 and 1. So I'm going to first get the problem as minus 1 and 1. Then I'll try to figure it out as we go. Now, I said that this is where you are allowed to use that technique of passing the square root around, and then you get x equal to plus or minus 1. Once you get x equal to plus or minus 1, automatically you pop it there, you will see that the function f is 0, right? Or function g is 0. Now the question is, right? If that is the case, what will be? Will that affect our problem? Will that affect our range? I said the range, I said here, for all these x's, that in between minus infinity to minus 1 union 1 to infinity, the range will always be positive. Anything I pop there is positive, except the problem in between minus 1 and 1. So what can we say about the range? The range will start from where? I just said that at 1 is 0, right? You see, what does it say when I said x equal to plus or minus 1? You can transform it into something else. You say the function was called g, right? You can say g of 1 is equal to 0. G of minus 1 is equal to 0. So that's the only thing I wanted to know. So it means that in this interval that I said in the set of real numbers, as minus 1 and 1, right? Minus 1 and 1, they are included. So I try to see what is f of 1, what is g of 1, what is g of minus 1. G of 1 is 0, g of minus 1 is 0. The moment I get g of 1 is 0, g of minus 1 is 0, I come here to confirm this greater or equal to 0. Why greater or equal to 0 means the range. That is automatically the range. I wanted to check if the range will include 0 or it will exclude 0. So then our range is y greater or equal to 0. So it means that all the positive y values from 0 going onward, that is all our range. So that is become from 0 up to where? Up to infinity. So our range for G is 0 up to infinity.
Okay.
Great. So
Yeah.
well, but we have given so many examples, so it means that you can let me see, go back there. I didn't address all of them, so you can practice some of this that I hear. Oh, okay. For the same one, let me just trick this same one around as a homework, so you guys will tell me about it next time. Where is it? I'm going to give you another homework. Is let me put it in. Homework should be a Greenland, right? I'm going to say find or determine the domains and range for the given functions. I write like a doctor, guys. I do apologize for that. Number one, I'm going to say f of x equal to 1 divided by the square root of x squared minus 1. Number two, what I mean by doctor, not doctor in mathematics, but doctor in in the hospital, you know, those ones. The nasty doctors, those give injections, right? G of x, I'm just going to tweak it as 1 divided by the square root of, let's say 1 minus x squared. I just twist it around, right? Then number three, h of x is 1 divided by x. Then number four, is that enough or should I add you more? K of x equal to x minus 1 divided by x squared minus 2. Do you guys want more? I think
No, it's enough.
there are several of them there that have been there. Maybe let me just add one last one, number 5. Something that I always wanted to say, maybe square root of x squared minus 9 divided by, let's say, x minus 2. Okay. Should I take x minus 4? I don't know. Yeah. So I think that's more than enough as a homework, right? Let me call it this one. I'm going to call, let's say, L of x. Yeah. Okay, you need to find the domains and the range for every given functions. I'm not sure because we haven't addressed the trigonometric functions, logarithmic and exponential. So we keep them at base for now. Great. Let me go back to see if there are any other question. Guys, any question?
How do we get a textbook for this module?
How do you get a
Textbook,
Facebook?
yeah, for this module.
How do you get a Facebook for this module?
Textbook
Oh,
or
textbook. Oh,
snap.
we mentioned earlier on that you get it online. Just type, someone assisted us here. I said that you go and copy that where it says, I'm not sure if it's open text or something like that. You paste it on Google and then you type, or you can just type the name of the book, Precalculus by J. Abraham. So then you can get that book when you use it. It's the same one. So it's not, I don't have the copy, so but it's fine. I'm going to request from the library if I can get a copy. Alternatively, you go to the library website and then just type UNISA library. For those who are around, they can actually even go to the library in Florida or in McLean or in any library you have near you. You can just ask them how to get that book. You can get the hard copy there. If you need soft copy, you go to the library website and then you also just try to type the name in the search button, the search engine for the library. Then you get the book. I think you can get the soft copy in there. All right. Any question, guys?
Sir,
Yes, go ahead.
which notation are we using? Is it the interval notation, like you've been doing with the examples that you've been doing with us throughout?
Yes, I forgot to mention earlier on that you see when I use the curly bracket is only for the set of integers and the set of natural numbers. I supposed to mention the notion of subset when you are in the set of real numbers. You see, in the set of integers, I use something like this, like 1, 2, 3. I use other sets like 4, 5, 6, and so on and so forth, right? So these are the subset in the set of integers. So because you can only count them 1, 2, 3, and stuff like that. However, in the set of real numbers, the subset is not given by this notation. You see, when I use R, I was using something curly bracket, round bracket. So now These are here, these ones are subset in the set of natural numbers. Let me use this color for vision. These are subset in the set of natural numbers and also in the set of integers. This is also in the set of natural numbers. Let me write by n. They're also subset in the set of n. So if I also add, let's say -4, let's say -3, 1, and 7, this is also the set of integers, right? Now, and also in the set of rational numbers, you cannot use this technique, right? Because of you have infinitely many elements there, so you can't count them. In the integers and the natural numbers, because you can count them, that's why we use those braces or those curly bracket in another sense. However, now in the set of real numbers, so you see, if you take the real number, this be this way, so we have 0 here. If you take, let's say, just the interval 0, 1. The interval 0, 1, there is half, there is quarter, there is 1 over million, 1 over pi, 1 over 100, 1 over billion, 1 over trillion, and so on and so on and so forth. 1 over zillion, and so on and so forth. It never stops, right? Even 1 over zebra, 1 over dog, 1 over cat, you'll find them there. So just the interval 0, 1, it's got infinitely many that we cannot count, all of us here, even if we count it differently. Now, the question is that how do you represent this? They cannot be represented in the same way as the way we did when we represent them in the set of integers and the set of natural numbers. However, then there is this notation. So if, let's say, is include, so when it is a full dot, then I can say the interval is called interval 0, 1. So it's interval. So the subset now become interval. So this is a subset of the set of real numbers. So then in the same venom, you can have the subset -1, 0 with a 0 open. So which means you have it. The square bracket stand for close, which means that 0 is included. So if I put half square bracket and then half round bracket, the question is, how do I represent this? Visually, if this is the set of real numbers, then if you have 0 here and then you have -1 here, then this one you present it with a full dot, and then this one, it should be a round dot, you see, from here to here. So this is the set -1, 0. So this is the set like this, -1, 0. So close at -1 and then open at 0. That's what it means. So the round bracket stand for open, and then the closed bracket stand for closed. So now in the same way, I can also have -1 and 0. So it's open both sides. So if I represent it, so it's -1, 0, so it's open here and open here. So I put by 0 open to say it's open, not a full dot. Then in the same way, you can also have it like this, open from -1 and close as 0. So it means that it's this side. Here is a full dot, and then here is a round dot if this is -1 and then this is 0. Now the question is that how do you represent it in terms of x? In terms of x, here it means that x is in between -1 open and then 0 close. So 0 is less or equal, and then -1 is strictly less than 1. And then for this one above here, this one start from -1 is strictly less than x, strictly less than 0. And then in the same way, for, I think, I don't know, where is it? For this one, -1 strictly less than x, strictly, I mean less or equal to x and strictly less than 0. And then for this one, 0 less or equal to x, less or equal to 1. So this is how you represent them in terms of intervals, and as an open, fully open with both sides, or fully closed both sides, or half open, which is called semi-open one side, or half open, which is actually called half closed, sorry, which is actually also called semi-closed, or half open on one side. I mean half closed on one side. So this is how you represent the intervals in R, as opposed to the way you represent them in the using the braces or the curly bracket in the set of integers and the set of numbers. So the subset, which on their own right also called set. So those sets are subset of the set of real numbers, or you must find in some instances since they are subset of the set of real numbers. So whatever things that you do, addition, multiplication, whatsoever it is, division, and so on and so forth, you can also do it in those subsets because they are on its own right. They are also set under condition that you stay restricted within that specific place. I hope that assisted with your question. Let me see, where am I now? Okay, any other question, guys?
Hi, sir. I have a question.
Yes, go ahead.
In the assignment, there's a
Yes.
question where we have to factorize, but it's for 4 marks. I'm not sure
Yes.
if this there was. I'm not sure if there's steps for that factorization. There's for me there was no steps. I could just go straight to what the two brackets are. Is
Yes,
that a
I
mark
fully
or
I fully agree with you. So let me say I give you a function f of x equal to x squared minus 1. You can easily factorize this as x minus 1 times x plus 1, or you can write it as x plus 1 times x minus 1. It doesn't matter which one is first. So yes, if the previous lecture I make it 4 marks, that is fine. So we mark it as 4 marks. So I know that the full marks are not fully. So if you get this correct, so you get 2 marks here and then 2 marks here. So that is fine. So you consider it as full mark given to you. So that is considered as a support. So I think, well, I can reduce it if you want to. You can go and reduce it to 1 mark or
I
not give
think
you mark at
what
all.
confused me was
No,
that it was so
no.
many marks for these so little steps.
Yeah, it's that's why. So it's like a 4 marks for so little step. Yes, 2 marks if you get the first one right and the second one right, also 2 marks. If you get the first one right and the second one wrong, you might get just 2 marks for the first one, and then you won't get absolutely anything for the second one. Or maybe if the lecturer is lenient enough, will give you a half extra mark.
So it does not matter which sign you start with. Like you can start with positive or negative.
Yeah, it doesn't matter. So you can have it as x plus 1 times x minus 1. It doesn't matter in which order.
Okay, thank you.
Thank you, sir.
All right. Any other question, guys? Yes, the max allocation was a bit too much. So I we left it like that for now. So we'll see some of the things, we'll address them maybe when I do the study guide and I just do the assignments myself as well. Any other question?
So assignment 3, so you'll be doing assignment 3 since it's not loaded.
Oh, okay. It's assignment 3 is not loaded. Let me check. I can't remember.
No,
Is
I
it
think
loaded
there's
on?
only assignment 1 and 2.
Okay, then that's fine. Then I will do assignment 3 myself. Yes. Thank you so much for that. Any other question? Okay, guys, if we don't have question, then I think we had issues of time management. We bypassed by in fact 30-minute extra. So let's see so that at least next time we won't go beyond that, so that we can keep it as simple as possible. All right. I guess no any other questions. There is no question in the chat, so I can stop the recording, right?
Yes.
Yes, sir.
Okay. Thank you so much, and I'm happy. Thank you for all being here. I also hope that next time you also come in numbers, and you can please spread the word so that all you